Hello, everybody. This is Jason from Children's Museum Houston. I am the Science Outreach Manager as well as a Life Science Educator here at the museum. And today I have some very cool guests with me. I have Michael from Premier Oilfield Group and his daughter Rachel, and they are going to do a really fun activity with us. So say hello, everybody.
Hello. All right. So we've got these pores and they're getting smaller and smaller as the rock is getting compacted. But with hard sand grains like this, you can't completely compact a rock just by loading it, just by putting more sediment on top. These grains are too strong. They're not going to collapse. Okay. So there's still going to be pore space. So what happens is minerals, if the temperature and the chemistry of the pore water is right, which it almost always is, minerals will start to precipitate and close up the pores just by taking up space, okay? And the main minerals that are the culprits are quartz. And what Rachel is drawing here is, this is a quartz grain in sand, and when quartz starts to precipitate in the sediment at depth, it already has quartz grains that are its buddies there, so it just jumps right on the quartz grain, and the crystals start growing right on the quartz grain. So it grows out from the quartz grain. They're even called quartz overgrowths. But quartz cement almost always starts on the quartz grains. Okay. Now, the other most important cement are carbonate cements, the most important of which is calcite. Okay. So that's calcium carbonate. Now, calcium carbonate, there are a few maybe little calcite pieces in some sandstones, but not that much. Calcium carbonate, though, can just start precipitating in the pore anywhere. Okay. It'll fill up whatever space is there if the chemistry is right and it can precipitate. Okay.
Nice.
So these two guys are the biggest culprits for shutting down, for completely closing down porosity. And when you close down porosity, the more cement you get in the rock, the harder it gets.
Okay.
Okay.
I
So
am learning
now
so
what I'm
much.
going to do is show you how geologists, so I've talked about this, we've talked about cements and pores and stuff, but these are all things that are tiny. They're all like less than a millimeter, some cases way less than a millimeter. How do we see this? How do we look at this stuff? All right. So we do have some techniques, and I'm going to show you a PowerPoint in a minute, but first of all, I'm going to show you what we do to the rock to get it ready for that. So I'm going to come a little closer over here. So if we take a sandstone like this and we want to see what's going on with its pores and grains, we can take a little chip out of it, about like this. Okay. Then we polish one side really well, and we glue it to a glass slide like this, and then we trim it off and polish it all the way down till it's only 30 micrometers thick. Okay. Super thin. We call this a thin section. So this piece of rock is polished down, and that will actually transmit light so we can look at it in the microscope. And we can see all the different features. And this is something that this is like kind of a real love of mine. I've been doing this almost my whole career, started doing it. This is like the coolest stuff to me. So the next thing we'll do here is we'll put up a PowerPoint, and Rachel and I will walk you through some examples of how sediments compact and the cements will precipitate.
Nice.
Okay? So this is the way geologists look at these fine features in this case, sandstones and mudstones that we're talking about today, but in any kind of rock, in limestones, in igneous rocks, volcanic rocks, whatever. This optical microscope has been around, not this one, this is a brand new one. These are very fancy and they're very sophisticated and very good. But microscopes like this have been around for 130 years. Okay, so the geologists have been looking for over 130 years. Geologists have been looking through these things, looking at rocks. So it's a pretty time-honored way of looking at things. Now, on the right is a piece of equipment that's been around since the 60s and keeps getting better and better. And that's called the scanning electron microscope. Now, where the microscope the optical microscope lets us go down to about, really comfortably about 200 times magnification, the scanning electron microscope will let us go to 5, 10, 15, 20, 50,000 times if we want. Okay. So we get to see a lot closer in the rock. So let's go ahead. Now I'm going to set this up, and Rachel's going to show you the details. So this is a sandstone. And the thing I forgot to tell you was with that little chip I showed you, what we do is so that we can see the pores is we put it in a little container with blue epoxy and we pressure it up and force that blue epoxy into all the holes. Since there are almost no blue minerals, the only blue thing that we can be seeing in the rock is the epoxy, which is the pore space. So that's how we can very easily see pore space. So all the blue you see in here is pore space, okay?
Nice.
So go ahead, Rachel, show them what you put. Okay, so it's not squished. The grains are still packed. They're not tight together. Lots of pore space between us, and we can't see any evidence of cement, right?
Right.
Okay,
Ah.
so here's another one. Here's the next step. So we're going to walk our way down to a hard rock. So go ahead, Rachel. You can. So this is
not squished. Some quartz glue. Still lots of open pores.
so push the next one. Show where the quartz is.
Ah, good knowledge.
So see all that. Yeah, go ahead and all around in there, all those sharp, straight edges are quartz cement that is growing in the pores off of a quartz grain. Okay, so it's starting to bind the rock together.
Nice.
Okay, Pumpkin, go ahead. All right, now we're taking it to another step. Go ahead, Pumpkin. It's more compacted. Okay, you can clearly see more quartz cement, and there's less pore space. So Rachel will show you where there's some quartz cement here. Go ahead. No, if you hit the next one, I think it's gonna.
Blink.
Yep. So remember so show all the hard edges.
Here a bit, and yeah, there too a bit.
So anytime you see kind of like those triangular shapes, like facing into the pore, that usually means that there's quartz growing there. So this rock's getting harder. It's getting less pore space as it gets buried and it gets cemented. So let's go to the next one. Now, this is, if you're looking for oil or gas or water, this is a tragedy, okay? Because it's all over. This sandstone has been compacted and has been completely cemented by quartz. So go ahead, Pumpkin, you go ahead. So what Rachel's point, you can make out, show the grain shapes, just give them an idea where some of the grain shapes are.
Here.
Yeah. So that's a grain, but it's completely surrounded by quartz cement.
Mm-hmm.
Okay. And the picture on the right is, these are all through the optical microscope. The one on the right, we're using a different filter, which just allows us to see a little different view. And that also is, you can see it's completely cemented. I think go ahead and hit it again. I think lots of quartz cement. It's like where the picture of Rachel is pointing, that all those pores are completely filled in with quartz cement, no porosity left. In oil field language, this is called tombstone.
I like that. Tombstone.
Okay, go ahead. Now, so let's talk about the scanning electron microscope. Now, this isn't really high magnification because we can study sandstones in there, where before with the optical microscope, we're looking at a flat section of rock. Here we can see things in 3 dimensions. Mm-hmm. So you can see this is another sandstone sample, but Rachel will show you, do you see all those triangular faces on there, on the grains?
Yes, sir.
That is quartz cement growing on the quartz grains. Okay,
wow, really noticeable.
It's compacted, but there's still pore space. See, you can see those holes in there. Mm-hmm. Okay, there's still porosity. There's still pores in this rock that can hold water, oil, or gas.
Got it.
Okay, now we're going to move on to our other culprit, which is carbonate cement, mainly calcite. Okay. So if you look at this rock, it's not very compacted. I don't think I can see, but maybe a tiny bit of quartz cement in there somewhere. But it's got one crystal of calcite that is starting to cement the rock together. But that's just one little isolated crystal. So it's not really making the rock hard or destroying the porosity yet. But as we'll see in other cases, it can be different. So not compacted, good.
Okay. Oh, wow.
Here's another version of tombstone. The cement, you see those things that kind of look like grains with lines going through them?
Mm-hmm.
Okay, those are actually calcite crystals. That's a common feature of calcite, those lines. And that calcite is filling up all the pore space. And if you look to the right, there is the identical picture. We just had the other filter in, and the calcite looks silver. Okay.
Mm-hmm.
And you can tell that the quartz is like white and grayish and on the right, so you can tell it from the quartz. So that rock has all its pore space has been filled up by calcite.
Okay, that's cool.
And then good. And just to show you, they're not mutually exclusive. In fact, most sandstones have 2 or 3 or 4 different cements in them. Some may be major, some may be minor. But you can see that this has a quartz cement that's growing off that grain, nice sharp edges. That happened first. And then the next thing was calcite, the silvery stuff there, filled all the rest of the pore space after the quartz cement.
Got it. I'm learning a lot from you and Rachel. A whole lot.
Okay, so that's kind of our sandstone story. Now, shales are a little different. This is a thin section looking in the optical microscope of a shale. And even though you can see lots of cool stuff, it's not that helpful for porosity. You can see the basic stuff. What color's the clay mostly, Pumpkin?
Just mostly brown.
The brown, it's all that browny stuff. And then the bright grains are silt grains that are quartz or feldspar or some other. And the thing right here with the little whirly things on it right here, that's actually a little tiny fossil.
What was that again?
It's a fossil. It's actually, I think it's what's a foraminifera, I think.
Nice.
I'm sure you'll get some responses that that's completely wrong, but so anyway, so mud is you can see cool features in there, but you really can't see any porosity when you're looking in the optical microscope. So we have to go to the SEM on that. And this is at an extremely high magnification. So that little scale bar down in the lower right, we've been looking at, a lot of the photos we've been looking at are about 0.1, 0.2, 0.3 millimeters on that scale bar. This is 1,000 times bigger.
Wow.
So we have gone down, up in magnification, down, getting up close to the rock 1,000 times. So what Rachel's just pointing to right there, those are some squished clay flakes right there. And then there is actually a pore. But
that little one right there. Yeah.
It's tiny, tiny, tiny compared to what you would see in a sandstone.
Yes.
So that's why when people try to produce oil or gas out of shales, that's why they have to frack them, because they have to break the rock so that they get more exposure to these tiny little pores, because that's where the oil and gas it needs to come out of. So yeah, I mean, I was just going to ask if you had any questions, just basically on what we saw here. And of course, if anybody views the videos and they want to send us questions, we'll be happy to answer them.
Actually, you answered a lot of the initially, like as you were doing it, I was like, I have a question, and then you were like, you would answer like boom, boom, boom. So I'm like, you actually answered everything I was going to ask, which is great. So I do thank you for this. This is amazing. Premier Oilfield Group has done a few videos with us, and we hope to do more. Hopefully, Michael will be interested in doing more, especially with Rachel, because we like having Rachel here with us. One question I do have, is there any way someday we could go to Premier Oilfield Group and look at your electron microscope?
Oh, absolutely. I think I've been kind of hoping we could do that. I mean, as COVID is getting under control, we would love to have you guys come over.
We'd love to come then. So cool. Well, as Michael said, if you have any questions, please go ahead and put them in the chat. We will monitor it and we'll ask questions as we can. They'll probably come through me, because I'll just send them over to Michael and say, Michael, send them back to me, and I'll send them out. Or they even come through our Henry, who does a lot of our, our PR work. So that's great. Last thing, if you are watching this on YouTube, please hit the subscribe button. If you do that, you'll get notifications of all kinds of cool stuff that we're doing, like these live videos that we're doing with Michael and other people at Premier Oilfield Group. With that, I want to say goodbye to you. Hope you have a good day. And let's say goodbye to Michael and Rachel with big thumbs up and smiley faces and all that good stuff. And Can't wait to go down and see that electron microscope. Thanks a lot, y'all.
All right, thank you. Take care.